In this video, we are going to see some of the examples in double integral to find the area of the graphs which are given. So the first example is find the area bounded by the ellipse using a double integration. So we know this is a equation of ellipse and this is a rough graph of ellipse. Um, so in ellipse, these four areas are same. So just by finding the first area and multiplying it with 4, we can get the total area of an ellipse. So let's start. So double integral 0 to b root of 1 minus x square by y. This is nothing but the equation of the ellipse. So first step, we have to take the strip. You can take a vertical strip or horizontal strip. It's based on you. That's not a problem. That doesn't matter. So here they took a vertical strip. So 0 to limit is nothing but the equation of an ellipse. So 0 to equation of ellipse with respect to y, because it is a vertical strip. So vertical strip in the sense with respect to y we have to integrate, and then the outer integral is 0 to a. It's 0 to the a, that is in x-axis. So with respect to x. So these are the simple integrations. So upper limit minus lower limit and blah blah blah. These are simple self-explanatory. Try to do it and cross-check with this. And the second question, using double integral, find the area enclosed by the curve y is equal to 2x square and y square is equal to 4x. So while seeing it, you can find this is or the equation of a parabola. So how to graph this parabola? There are many videos in YouTube which are present. So just go through that videos to get how to graph a parabola by the equation we got. And so after graphing it roughly, they took a strip vertically and 0 to, so this is a very important. So you have to find the cross section where it crosses, where it bisects each other, where it crosses each other. So to find out, you have to just equate it. So just put y is equal to 2x square in this equation so that you can get the x coordinate of this, and after putting x coordinate in any one of the equation, you used to get the y coordinate. So by solving this, we got 1 comma 1. So they just solved it here. 1 comma 1 is the cross section. And now by double integral we have to find the area as usual. So area is equal to double integral dy dx. So y it's nothing but the equation of lower limit is equation of the parabola y is equal to 2x square, and upper limit is the equation of the parabola y square is equal to 4x. So after putting the limits, y is equal to 2x square and y is equal to root of 4x, and in x coordinate it's nothing but the where it crosses each other. So 0 to 1. So 0 to 1 is with respect to x, and 2x square 2 root y is limit for y with respect to y. So after simply solving it, this is self-explanatory steps, simple integral equation. So just solving integration, so you used to get 2 by 3. So that's it, very easy. And a third example, find the smaller area of a area bounded by the y is equal to 2 minus x. This is a line, and x square plus y square is equal to 4. This is by seeing this you can find this is a circle using double integration. So we drawn a circle and this is the line. So how do you know where it crosses? So just put this equation in this equation so that you can get the where it crosses each other, the points where it crosses each other. And again, simply as a double integration, you have to take the strip. So strip lower limit is nothing but the equation of a line, and upper limit is nothing but the equation of a circle. So equation of line, equation of circle with respect to y. Why with respect to y? Because it's a vertical strip. So if you want, you can take horizontal strip also, no problem. Dy and then dx is 0 to 2, because from 0 it's going to 2. So from 0 to 2 in x direction with respect to x. So these are the simple integration steps. Just solve it and cross check it with it. Don't see as don't read max, just solve max. So this is the answer. And find the area bounded by the parabola. So this is parabola, just these two are parabola, double integral and evaluate it. So how do you know that this parabola is something looks like this and the other equation looks like this? How do you know that? Again, I'm saying that there are a separate video for this, how to trace the parabola with the equation in Cartesian coordinates. So just go through the video so that you can find how the parabola looks like. So there are some of the simple formulas to find out it how it looks like in a graph, so that we can roughly draw it. So after drawing it roughly, they took it a horizontal strip, and you have to know where it crosses each other. So for that, as I said before, you have to just equate this both, just by putting y square is equal to 4 minus x in this equation. You can find the x coordinate, and after finding x, substitute any of the x in any of the equation, so that you can find the y coordinate. So simply you used to get uh, the cross where it crosses, so the point where it crosses you used to get. After that, area is by using double integral we have to find the area. So limit is nothing but the lower limit is p, upper limit is q. So p is nothing but the equation of this parabola, that is y square is equal to 4 minus 4x, and upper limit is y square is equal to 4 minus x. So we need in a form of x is equal to. So by keeping x in the right side alone, by keeping putting everything on a right side, by transferring everything on a left side and right side, you used to get x is equal to 1 minus y square by 4. And again here, if you keep x this side, and you take this 4 to left side, and multiply it both by minus blah blah blah. Simple guys, these are all simple things. And x is equal to 4 minus y square used to get. So these are the lower limits with respect to x, because the strip is horizontal. And then y, so with respect to y, what would be the limits? So it's nothing but this point to that point. So it's 0 to uh 2, I mean why it is 0 to 2. It's from minus 2 to plus 2 now. Why it's 0 to 2? Because these both areas are equal. This is symmetric in shape. So by finding this area alone, let me draw it. For finding this area alone, we can multiply it with 2, so we can get the whole area. So that's the idea here. So just multiply it with 2, so used to get. But before that, if it is not symmetrical also, you can do it when this result is even function. What does mean by even function? F of x is equal to something x, f of minus x will also come as x, so that's called even function. F of minus x is also will come as x, so that's a even function. So these are the simple steps of an integration. You used to get 8. That's it. Try to solve it. And another question, using a double integration, find the area of a parallelogram. Okay, parallelogram whose vertices. Here no equations are given. We have to find the equations. So how can we do it? A simple, we have the formula, which is y minus y1 by y1 minus y2 is equal to x minus x1 by x1 minus x2. This is the formula to find the equation of a 2 points. So just by graphing the points and joining it, we used to get the parabola. Now we have to find the equation of this CD, AD, AB, everything using this formula. After finding it, they took a strip horizontally. As it is a parallelogram, this area will be equal to this area. So just by finding the one area and multiplying with 2, you used to get the whole area. So taking a strip what horizontally, so pq, what is a p? P is nothing but the equation of a dA, and q is nothing but the pa. So after putting it in the equation and finding the equation of the lines, so it would be the limits. So lower limit is the equation of this, and upper limit is the equation of this line. And after that, you used to get this. And for limit 0 to 1, it's with respect to y. So how to find it? It's 0 to 1. So d point is the upper limit, 0 is the lower limit, because from here to it can go up to this. So 0 to 1, and simply solving the integral equations, you used to get answer 3 by 2. If any doubt, comment below so that I can help you personally. So these are the questions, you can solve it to get more idea about this, and these are the answer for that. Now we are going same thing but in a polar form. So finding the area in a polar form. So polar form, we know that there is no something called x, y, something something. Here everything is r and theta. R is nothing but the distance in the, I mean mostly it's a distance from the pole, they used to say. And theta is nothing but the angle, we know that. So area in polar coordinate, the formula is this. There, as usual, simple double integration, but here this r is mandatory. Everyone will make mistake in this r. They used to forget this r. This is very important, and you should not replace this r with this 2 cos theta or this 4 cos theta. R should be r there. That's very important. So these are all the circles after drawn after graphing it roughly in coordinates, I mean in the graph. So area is double integral of what's its a limit. How do we take the limit here? So it's by if you see, we can take strip in between this, because in between this area is asked. So lower limit is nothing but the equation of a smaller circle, upper limit is nothing but the equation of a bigger circle. So what is the equation of a lower circle? Which is 2 cos theta, and upper limit actually, I mean upper limit is the equation of a bigger circle, which is r is equal to 4 cos theta. So they put it, and with respect to r we have to integrate it. So after integration we used to get this, and now theta is minus pi by 2 to plus pi by 2. From here the strip will goes along this to this, so minus pi by 2 to plus pi by 2. So that's the limit of theta. After solving it, you used to get this simple. And find the area for one loop of a leminiscate. What is leminiscate? Leminiscate is nothing but it looks like this, an infinite symbol. So this is a leminiscate. And how do you know this equation is a leminiscate, and this leminiscate will looks like this? So as I said before, there is a separate video how to trace a lemniscate in a Cartesian coordinate or in a polar coordinate with the equation. So just look the video, just go back to the video and search in YouTube, so that you can get an idea how to graph it. And so now we have to find the area. That's our main intent. um, So this is a double integral, and that too they are asking only one loop of the leminiscate. That means this is not needed. Only this loop is needed, and from r is nothing but 0 to the equation of a leminiscate. So 0 to equation of a leminiscate, which is r is equal to root of, if we bring back the square this side, so that square rooting in both sides will get this as r is equal to equations. I mean the equation of a leminiscate. So and then theta is nothing but minus pi by 4 to plus pi by 4. How do you know that minus pi by 4 to plus pi by 4? To find the theta in a polar coordinates, you have to just equate r is equal to 0. So if you put r is equal to 0, you used to get a pi by 4, because if you put r is equal to 0, this a will go that side, so that cos 2 theta is equal to 0 used to get. So when cos theta is 0, cos 90 is 0, so 2 theta is equal to pi by 2 you get, and that 2 will come this side, so the theta is equal to pi by 4. So that's how you get minus pi by 4 to plus pi by 4 as a limit in theta. So there is a property of integrals like minus a to plus a is equal to 2 integral of 0 to a, if and only if the inner function which are present here are even functions. So these are all, these are all simple steps to solve the integrals. So this is the answer which you got. Just cross check after solving this. And I have another question. Find the area of a loop of a curve r is equal to a sine 3 theta. So this is again how to graph it. We can't know it. If we graph only, we can predict the theta, and we can get an idea after graphing it only. So for that, you have to refer a separate video which is present there. So how to graph a loop or a curve in polar form, so that you get an idea. So now we have to just find the area. So r is equal to a sine 3 theta. So double integral r dr theta, we know this is the formula, and r should be r. We should not replace it with something a sine theta or something. R should be r, and this limit is nothing but 0 to the equation of the curve. So this is the equation of a curve, and theta is nothing but 0 to pi by 3. How 0 to pi by 3? Just put r is equal to 0, used to get that theta. After solving this is the answer. So these solving steps are easy. If you can't understand it, please comment below. and find the area which is inside the circle and outside. This inside outside is very important, guys, because if you just collapse it, you used to get a wrong answer. So please be careful in inside and outside. Inside the circle and outside the cardioid. So this is a circle, this is a cardioid, equation of cardioid. So just graph it, and inside the circle and outside the cardioid. This is inside the circle and outside the cardioid, which means uh, this is the portion we have to find. This is a portion we have to find. So lower limit is cardioid and upper limit is equation of a circle. So we have to find where it crosses each other. So for that you have to equate this to r is equal to r. So 3a cos theta is equal to a into 1 plus cos theta. If you equate it, you used to get where it crosses, and theta also used to get that like only. If you equate it, you used to get theta. So 0 to pi by 3 is, we got it by equating this both, and equation of a circle is given and cardioid also given, and simple integration steps, just look it up, it's self-explanatory, that's it. And now find the area common to r is equal to a root 2 and r is equal to 2a cos theta. So find the area common to, so r is equal to a root 2 is in a circle and r is equal to 2a cos theta is also a circle. So by graphing it, we used to get this as a common area. But here two double integral is needed, because if you look at this line, from this line the equation of a circle gets changes. Let me show you. From here to here, it's equation of a bigger circle. From here to here, it's equation of a smaller circle. So this line separates these two. So for this you have to take two separate double integrals, and then you have to add it. So two separate integral, and how do you got this limit? It's nothing but 0 to equation of a bigger circle. I mean equation of a smaller circle. They first took OQ. So 0 to, no, wait. No, they took equation of a bigger circle, r is equal to a root 2. So 0 to equation of a bigger circle, I mean they first took OP, and theta is nothing but a 0 to pi by 4. How do you know that is pi by 4? So for that you have to equate these two. As I said before, to find where it crosses each other, you have to just equate it. So you can get this, and the theta used to get as pi by 4. So and another thing is, another double integral is pi by 4 to pi by 2, from this to this, from 0 to pi by 4 and from pi by 4 to pi by 2, and limit is nothing but 0 to the smaller circle and pi by 4 to pi by 2, you know it. And simple solvation and addition, these are all self-explanatory. If you can't understand, as I said before, please comment below. And this is another question. Find the area inside a circle. Okay, this is a circle, but lying outside the cardioid. So this is a cardioid lying outside. So circle, cardioid, outside the cardioid, this is a region we have to find. So as if you take strip or something here, so lower limit you used to get as a equation of a cardioid, and upper limit you used to get as a equation of a circle, and theta used to get 0 to pi by 2. So double integral, equation of a cardioid, equation of a circle as upper limit, and theta is 0 to pi by 2, r dr d theta. After you solve, you used to get the answer like this. These are simple steps. By seeing it, you can find out. And these are the exercise in polar form, finding the area. So just go through it and just try to solve it. These are the answer. Cross check. Sometimes these questions may contain some spelling mistakes, or I mean printing mistakes, so just ignore it. So bye bye. If you really like this video, if this content is helpful, please hit the subscribe button. Simple, it's free, nah, just do it.